Good morning, students. Today we are going to see the homogeneous function and how to apply Euler's theorem for the homogeneous function. First, we'll see the definition of homogeneous function. So let A is the set of all ordered pair x comma y, A less than x less than b, and c less than y less than d is contained in R square. So we are going to say f is homogeneous. Under what condition it will be homogeneous? So f is a function from A to R. From this set to R, we say that f is a homogeneous function on A if there exists a constant p such that f of lambda x lambda y is equal to lambda p into f of x comma y for all lambda belongs to R and suitably restricted lambda xy such that lambda x lambda y belongs to A. This constant p is called the degree of f. This is the definition given. Okay, I'll explain with the one simple example. I'll consider the function f having two variables x and y, that is x cube minus 2y cube plus 5xy squared. Okay, we are going to check whether this function f is a homogeneous function or not. For that, what you have to do, you have to substitute in the place of x and y as lambda x and lambda y. Okay, so in the function f, wherever you are having x, it has to be substituted as lambda x. In the same way, y has to be substituted as lambda y. Here you see that I am going to substitute here. In the place of x, what I did, lambda x the whole cube minus 2 into, in the place of y, lambda y the whole cube plus 5 into, x is replaced as lambda x and y is replaced as lambda y. So here y squared, so lambda y the whole square. So apply the power, it is a lambda cube x cube minus 2 into lambda cube y cube plus 5 into lambda, here lambda squared, okay, lambda squared into lambda is lambda cube xy squared. From all the terms, what is common? Lambda cube. If I have taken out, what is remaining? X cube minus 2y cube plus 5xy squared. Okay, so now we can write f of lambda x lambda y can be written as lambda cube into, what is this? You are getting the original function f. If you can write like this, we can very well say f is a homogeneous function of degree 3. Why I am saying 3? So what is the power of lambda? That is 3. So it's a homogeneous function of degree 3. That is, you come to the definition of, if there exists a constant p such that f of lambda x lambda y is equal to lambda power p into the original function f. If you can write like this, so we can say f is a homogeneous function of degree p. Okay, so you want to check the function is homogeneous or not. What you have to do? You have to replace x and y by lambda x and lambda y. So how the function has to be written? So all the lambdas should be taken out and you have to get the original function back. That is, f of lambda x lambda y is equal to lambda cube into f of x comma y. Otherwise, f of lambda x lambda y is equal to lambda p into f of x comma y. If you can write, the function is a homogeneous function of degree, here it is 3, here it is p. Okay, so the power of lambda is called the degree. Okay, we'll see with problems. See the first problem, exercise 8.7. In each of the following cases, determine whether the following function is homogeneous or not. If it's so, find the degree. Okay, the function given as small f of x comma y. That means what? F is a function having the variables x and y. So it is x squared y plus 6x cube plus 7. So what you have to do, you have to replace x as lambda x and y as lambda y. Replace it. Here what has to come? Lambda x the whole squared into lambda y plus 6 into lambda x the whole cube plus 7. Okay, so when you apply the power, it is lambda squared. Here you are having lambda, so it is lambda squared x squared into lambda y plus lambda cube x cube plus 7, isn't it? So when you multiply lambda squared into lambda, it is lambda cube x squared by plus 6 lambda cube x cube plus 7. So you see that from all the terms we have to take lambda cube out. If it's so, the first term will become x squared by, the second term will become 6x cube, but here there is no lambda cube, so it has to be divided by lambda cube, upper 7 by lambda cube. So we have taken the lambda out, but we are not getting the original function. That's why I have written it is not equal to. Okay, if it is not equal to, we can't say the function is homogeneous. So therefore f is not a homogeneous function, because after substituting x as lambda x and y as lambda y, which is not equal to lambda power p into the original function. So in the original function, here you are having 7, but here what do you got? 7 by lambda cube. So that is not the original function. So therefore f is not a homogeneous function. Okay, come to the problem number 2. You see that h of x comma y, that is the question is given. H is a function of x and y variable. Okay, so you just substitute, we have to check whether the function is homogeneous or not. So x and y has to be replaced as tx and ty. You look at that, in the place of x, lambda x, in the place of y, lambda y. So I have substituted in all the terms, and I apply the power. I will get 6 lambda squared x squared lambda cube into y cube minus pi into lambda power 5 into y power 5. Like that I have I have applied the power. Oh, see, look at the first term, lambda squared into lambda cube, that is lambda power 5. Here also lambda power 5. Here also lambda power 4 into lambda, so lambda power 5. In the numerator, lambda power 5 is common. So if you take it out, what is remaining? 6x squared y cube minus pi y power 5 plus 9 x power 4 into y. You look at the denominator, what is common? Lambda squared. So lambda squared, if you take it out, it is 2020 x squared plus 2019 y squared. So numerator and the denominator, you are having the lambda, so you have to simplify. So it is lambda squared is getting cancelled. What is remaining? Lambda cube. You see that h of tx comma ty is equal to lambda cube. What is this? You are getting the original function back. What is the original function? H of x comma y. This is h of tx comma ty. This function is a h of x comma y. So we can write lambda to the power 3 into the original function. So therefore we can very well say h is the given function h is a homogeneous function of degree 3. So why I have written 3? The power of lambda is nothing but the degree. Okay, so come to the third subdivision. So g of x comma y comma z. What is it? G of x comma y comma z. That is the function is given. So we have to check whether it is homogeneous or not. So for that, x is replaced by, what is that? Tx, and y is replaced by ty, and z is replaced by tz. Okay, when you substitute here, you will get 3 tx the whole square plus 5 ty the whole square plus t z the whole square. So when you apply the power, it is t squared x squared, here t squared y squared, here t squared z squared. Okay, so only the numerator terms are in the square root. So here in all the terms, what is common? T squared. So it's a square root of t squared into 3x squared plus 5y squared plus z squared. You look at the denominator, what is common? T is common. So if you take it out t, it is 4x plus 7y, isn't it? T is taken out means here 4x plus 7y, that is written here. So square root of t squared is what? It is t, and you have to apply the square root for the remaining function. So square root of 3x squared plus 5y squared plus z squared. T getting cancelled. So I can write that as t power 0. So g of tx, ty, tz is equal to, t is not there, t getting cancelled, so that's why I have written t power 0 into g of x comma y comma z. So what we can conclude, g is a homogeneous function of degree 0. Okay, so we come to the fourth subdivision, u of x comma y comma z. Okay, so you see that x, y, z has to be replaced as tx, ty, tz. So the first term is written and the sign second term as a trigonometry function, so I have applied inside. So in the numerator, what is common here? T squared is common. So when you take it out, what is remaining? Y squared minus 2z squared. In the denominator, tx into ty means it is t squared xy. T squared getting cancelled, you will get this original function. And here t into t is t squared xy. So from these two terms, t squared has to be taken out. If we taken out, it is xy. But here, no t squared is there. So it has to be divided by t squared. About what it is, you are not getting the u of tx comma ty comma tz, it is not equal to, what is that, u of x comma y comma z. Otherwise you can write t squared into, here you can write it is not equal to t squared into u of x comma y comma z. So therefore u is not a homogeneous function. If it is a homogeneous function only, we have to write the degree. So here it is not a homogeneous function, we can conclude. Okay, so next one, we are going for the Euler's theorem. So see that the same A is taken. A is the set of all ordered pair x comma y. A less than x less than b and c less than y less than d. And we are going to take a function. F is a function from a to r square. So if f having continuous partial derivatives, f is having a continuous partial derivatives and homogeneous on A. The f is a function, it's a homogeneous function on its domain, that is domain of f is A. Okay, with the degree p, then according to the Euler's theorem, we can write x dou f by dou x plus y dou f by dou y is equal to pf. What is p? P is the degree. Okay, so homogeneous function means you can write how to write the degree. So see that f is a homogeneous function and having continuous partial derivatives. If it's so, we can apply Euler's theorem for the homogeneous function. So Euler's theorem is what? X into dou f by dou x plus y into dou f by dou y is equal to pf. Okay, if exercise 8.7, second problem, you see that, prove that f of x comma y is equal to x cube minus 2x squared y plus 3xy squared plus y cube is homogeneous. So we have to prove that the function is homogeneous. What is the degree? So we have to write the degree and verify Euler's theorem for f. So if it is a homogeneous function, we can apply Euler's theorem. After that, we have to verify it. Okay, you see that first one, you have to consider the function. We have to prove it is a homogeneous. So homogeneous means x and y has to be replaced by tx and ty. So in all the terms, x is tx the whole cube. So it is t cube x cube. And here what you will have, tx the whole square, that is t squared x squared. Y is replaced by ty plus 3 into x is replaced as tx and y ty the whole square, that is t squared y squared, plus here what has to come, it is t cube y cube, because it has to be replaced, y has to be replaced by ty, but it is t cube y cube. See that from all the terms, what is common here? Here it is t cube. So from all the terms, what is common? T cube is common. If you take it out, what is remaining? X cube minus 2x squared y plus 3xy squared plus y cube. So f of tx comma ty, which is equal to t cube. What is this? This is the original function, that is f of x comma y. So if it's so, we can very well say f is a homogeneous function of degree 3. So f having the continuous partial derivatives and it is a homogeneous function with a degree p. Here your small f is a homogeneous function of degree 3. Okay, so we can apply Euler's theorem for this small f. So how it will be? X dou f by dou x plus y dou f by dou y is equal to pf. What is p? P is the degree. What is the degree we have written? That is 3. So 3f. So it's a homogeneous function we have proved and we have written the degree also and we applied the Euler's theorem for f. Next, what is the question is asked? Verify Euler's theorem. So verify Euler's theorem means you have to left side is equal to right side and we have to prove it. So see the left side, what you are having? X dou f by dou x plus y dou f by dou y. Okay, so each term has to be found. So first what it is? Dou f by dou x. So I have written the f here. That's a question. Dou f by dou x means what? You have to differentiate f partially with respect to x. Okay, so look at that, all the terms are in plus and minus. Look at the first term, it is x cube. When you differentiate, it is 3x square. So in this term, you are having x and y. But here you have to differentiate partially with respect to x means y is a constant. So from this term, first you take the constant out. What is the constant? Minus 2y. So it is taken out. What is remaining? X square. So if we differentiate, it is 2x. Come to this term. Here also x and y is involved. What is a constant? 3y square. Here remaining is x. If you differentiate, whose differentiation is 1. Okay. So what is y cube? It's totally constant whose differentiation is 0. So I have completed dou f by dou x. Okay, next here the Euler's theorem, what is the first term? X into dou f by dou x. So x has to be multiplied with this. So it is 3x cube minus 4x squared y plus 3xy square. So call this as 2. Okay, next, so I have completed the first term. Next we have to go to the second term. So here dou f by dou y. So go to the f and you have to differentiate f partially with respect to y. That means x is a constant. But the differentiation of the first term is 0. And here what is a constant? Minus 2x squared, that is taken out. Remaining is here it is y. The differentiation of y with respect to y is 1. And come to here, what is a constant? 3x is a constant. Y squared if you differentiate, that is 2y. Plus y cube, when you differentiate, it is 3y squared. So you have to arrange. Next, what you have to do? That term has to be multiplied with y. So when you multiply, this will become minus 2x squared y. This will become plus 6y squared plus 3y cube. That is written in the next page. You see to that? Yeah, you are getting. So what you have to do? So what is asked? You have to verify. So in the left side, Euler's theorem, what you are having? You are having x dou f by dou x plus y dou f by dou y. So the second and the third has to be added. Okay. So see that second term, first term, what it is? 3x cube. So 3x cube is written. What is the second term? Minus 4x squared y. So as a second term it is written. Next one more, 3xy squared. So that is written. It is added with these three terms. Okay, look at this. 3x cube I have written. So see that minus 4x squared y minus 2x squared y. So if you take it out, what is here? Minus 6x squared y. And plus 3xy square. Here plus 6xy squared. So when you add, it is 9xy squared and plus 3y cube. So from all the terms, what is common? 3 is common. If you take it out, what is remaining? X cube minus 2x squared y plus 3xy squared plus y cube. What is this? It's a original function f. So x dou f by dou x plus y dou f by dou y is equal to 3f. So we have verified the Euler's theorem for the function f. And we are moving to the problem number 3. So what is asked in the problem number 3? You see that, prove that g of x comma y is equal to x into log of y by x is homogeneous. What is the degree? Verify Euler's theorem for g. Okay. See the same question. Previous question, the same model, it is there, but the function is different. So g is a function of x and y. So it is x log of y by x. And you have to prove that it is a homogeneous. For homogeneous, what you have to do? X and y has to be replaced by tx and ty. So if we replace, it is tx into log of ty by tx. So tx into log of y by x. So see that everything is a product. So we can write g of tx ty is equal to t into what is this? G of x comma y. So we can very well say g is a homogeneous function of degree 1. How I have written 1? So t power 1. So it is degree 1. So by Euler's theorem, how you can write? X dou g by dou x plus y dou g by dou y is equal to pg. What is p? It is 1. So you are having, this is Euler's theorem. We have to verify it. So call this. So you have to take the left hand side and you have to prove it is equal to right hand side. The left hand side, first term, what it is? X dou g by dou x. So from that, what you have to find first? Dou g by dou x. You see now, I have taken the, what is it? G of the function g, that is x into log of y by x. Okay. So first term, differentiate g partially with respect to x. Okay, so here also you are having x, this also you are having x, x log of y by x. In both the terms you are having x. So you have to use the product rule to differentiate it. Okay, so product rule, first step, what it is? First term you have to write as it is. What is the first term here? It is x. So x is written as it is. And log of y by x. So log of y by x, how it will be differentiated? So you have to use the chain rule here. So first you have to keep the whole thing as x. So it is in the form of log x. What is the differentiation of log x? 1 by x. So I have written 1 by y by x. Next, what you have to do according to the chain rule, which is kept as x, that has to be differentiated. So y by x has to be differentiated. While you are differentiating, you have to differentiate partially with respect to ax. So in the y by x, x is in the denominator. So what is the constant? Y is the constant. So it is taken out. What is the differentiation of 1 by x? It is minus 1 by x squared. Okay. So the product rule first term is over. What will be the second term? Plus the v has to be written as it is. And you have to differentiate x with respect to x is 1. Okay. So see now, this 1 by y by x can be written as x by y into minus y by x squared plus log of y by x. You see that this y and this y getting cancelled, x into x is x squared. So here you are having minus 1 plus log of y by x. So according to the Euler's theorem, it has to be multiplied with the x. So x dou g by dou x is equal to minus 1 into x is minus x. So it is x log of y by x. First term we have completed. What is the second term? Y dou g by dou y. So first you have to find out dou g by dou y. How to find this? Go to g. You have to differentiate g partially with respect to y. And look at that. Here x log of y by x. So here two terms, but only one term having y. So you need not go to the product rule. Okay. So x is a constant. It is taken out. And you are going to differentiate log of y by x. Okay. So use the chain rule. So it is 1 by y by x. Now y by x has to be differentiated partially with respect to y. Okay. But y by x, what is the constant? 1 by x. So it is written out. But here what you are having? Y. So y, when you differentiate with respect to y, is it is 1. Okay. So 1 by y by x can be written as x by y. So 1x getting cancelled. So remaining as x by y. That has to be multiplied with y. So y into x by y, x by y getting cancelled. You are having x. So these two has to be added. So I have written the addition. So minus x plus getting cancelled. You are having x into log of y by x. What is this? It is nothing but g. So we have verified the Euler's theorem for the function g. Okay. Come to the next problem, that is the fifth problem. You see that if v of x comma y is equal to log of x squared plus y squared divided by x plus y, prove that x dou v by dou x plus y dou v by dou y is equal to 1. Okay, you see that here they didn't verify the Euler's theorem, but you have to prove that x dou v by dou x plus y dou v by dou y is equal to 1. You look at the left hand side of the result, what we have to prove. Okay, it looks like a left hand side of Euler's theorem. So Euler's theorem, if you want to apply, the function should be homogeneous. So first what we have to do now, we have to check the given function is homogeneous or not. So consider the function v of x comma y. It has to be replaced by x and y has to be replaced in v as tx and ty. So I have replaced it. So in the numerator t squared is taken out, in the denominator t is taken out. So t and t squared getting cancelled, you are having t here. It is log of t. So this, because this t we cannot take it out, so I have written v of tx ty cannot be equal to t power p into v of x comma y. So the given v is not a homogeneous function. But anyhow, we have to prove this result. So here, why this v is not a homogeneous function? Because the t cannot be taken out because of this log. Okay, but what you have to do, this log has to be taken to the left side. How it will be written? It is e power v. Here you are having v. Okay, so logarithmic function adoda inverse, when you bring it to the left hand side, it is e power v. So e power v is equal to x squared plus y squared divided by x plus y. Okay, so see now this has to be named as f. Here v is log of x squared plus y squared divided by x plus y, but f is x squared plus y squared divided by x plus y, or otherwise we can say e power v. Both are different. V is different from f. Here we have concluded v is not a homogeneous function. So here I have written how it is not homogeneous, but in exam you need not write this. So you can very well start from here. You have to write v is not a homogeneous function. Then you have to go for, you have to rechange it. So the log, when you take it to the left side, its inverse e power v. Okay, so for here you have to check the given f is a homogeneous or not. For that we have to substitute x and y in f has to be replaced by tx and ty. So you take this term, all the three are equal. To check the homogeneity, if you consider this one, it is easy for you. So it is t squared x squared plus t squared y squared divided by tx ty. So in the numerator t squared is common, in the denominator t is common. When you cancel, you will get t into x squared plus y squared divided by x plus y. So therefore f of tx comma ty, that is equal to t into x squared plus y squared divided by x plus y. What is it? It is equal to t into f of x comma y, isn't it? See that your f of x comma y is what? What is f of x comma y? We can write e power v, otherwise x squared plus y squared divided by x plus y. So here you are having, so t into f of x comma y. So we can very well write f is a homogeneous function of degree 1. Okay, so we can apply Euler's theorem for f. So here x dou f by dou x plus y dou f by dou y is equal to pf. What is your p? It is f. But you got this result. Okay, this is not the result is asked in the question. Okay, so what you have to do now? Here f, what we have taken as f is nothing but what it is e power v. So for the differentiation, if you consider e power v, it is easy. If you consider this term, you have to go to the quotient rule. Okay, so see now, in the place of f, I have substituted e power v. Here also it is written as e power v. Okay, you see that x is written. What's the meaning of this? Dou by dou x of e power v. That means e power v has to be differentiated partially with respect to x. Okay, so in the v, it's a function of x and y, but it is not explicitly given. Okay, so first you have to differentiate e power v. Okay, e power v, but the differentiation should be done partially with respect to x. So therefore dou v by dou x. You see that? dou by dou x of e power v. How to differentiate e power v partially with respect to x is e power v into dou b by dou x. In the same way here what you have to do, the differentiation is e power v into dou b by dou y, that is equal to e power v. So from these two terms what is common? E power v. If you take it out, x dou b by dou x plus y dou b by dou y is equal to e power v. E power v getting cancelled. So you have got this result. That is the result we have to prove. Okay, so we'll come to the problem number 4. What is it? If u of x comma y is equal to x squared plus y squared divided by square root of x plus y, prove that அப்படின்னு கொடுத்துருக்காங்க. Okay, so u is given. You have to check whether the u is homogeneous or not. Why I am going for the homogeneous? You look at the result. What do you have to prove? It is the left side of the Euler's theorem. So we have to check the homogeneity. So x has to be replaced as tx and y has to be replaced as ty. So in the numerator t squared common, in the denominator root t is common. Okay, you see the power of t here, it is 2. Here the power of t is 1 by 2. So if you arrange, it is in division. So the power has to be subtracted. T power 2 minus 1 by 2. That is equal to t power 3 by 2 into u. So we can very well conclude u is a homogeneous function of degree 3 by 2. So we can apply Euler's theorem for u. So therefore x dou u by dou x plus y dou u by dou y is equal to pu. What is p? It is 3 by 2. So you have proved the result. Okay, come to the problem number 6. If w of x comma y comma z, that is equal to log, okay, the long function is given and you have to find x dou w dou x plus y dou w by dou y plus z into dou w by dou z. It is the, what is it, left side of the Euler's theorem. So first we have to check the w is a homogeneous or not. So here you are having log. So if log or trigonometry function whatever comes, you see the numerator and the denominator same degree irundadana, it can be cancelled. So we can very well write w of tx, ty, tz is equal to some constant into the remaining எழுதலாம். But here log is there, you see the numerator. So when you substitute here, you are having t cube. Here t power 4, upper t power 7. Here also t squared, get t, upper t cube. This t power 4, t power 7. Here also you are having t power 7. But the denominator you are having t squared. So when you cancel, t power 5 will be in the inside. We can't take it out. But its conclusion is what? W is not a homogeneous function. But because of log, it is not a homogeneous function. Upper log has to be taken to the left side. How it will go? E power w. So you have to name that function as f. Now it is not w, it is your f. So if you want to apply Euler's theorem, we have to check the homogeneity. So x, y, z has to be replaced as tx, ty, tz. Already I have explained. So the numerator is t power 7 and the denominator is t squared. So you can write t power 5. You will get the original function of f. So we can say f is a homogeneous function of degree 5. Okay, so how the 5 has come? The power of t. So you can apply the Euler's theorem. So x dou f by dou x plus y dou f by dou y plus z dou f by dou z is equal to pf. What is p? P is 5 now. So you will get this result. Okay, so what is the result you have to prove? It is not in terms of f, it is in terms of w. So what is your w? W is a log function. So here you are having, in the Euler's theorem you are having f. So what is your f? We have found f has changed as, what is it? E power w. So in the place of f you have to substitute e power w. Okay, so I have substituted. Okay, so in the place of f as e power w. Here you are having the partial derivatives dou by dou x of e power w. But w is a function of x and y, but it's not given explicitly. So how the differentiation has to go? E power w into dou w by dou x. The same way, dou by dou y of e power w into dou w by dou y. In the same way here, do e power w into dou w by dou z. Here no partial derivatives involved, so you have to write e power w as it is. From all the terms e power w is common. If you take it out, you will get this term, that is equal to 5 e power w. So e power w getting cancelled, you are getting this is equal to 5. So this is the result we have to find. So the answer is 5. Thank you, students.